Okay, third graders, so this is week 5, lesson 1. We're going to continue on with our geometry lesson, so we're going to be talking about parallelograms, rectangles, squares, and rhombuses, okay? And you'll learn what all those words are. What you need for this lesson is your vocabulary book that you made last week, or maybe the week before, and then you will also need a pencil. Okay, so let's go ahead and get started. All right, so by the end of this lesson, you can say that you can explore the relationships among parallelograms, rectangles, squares, rhombuses, and trapezoids. We have a lot of vocabulary words in this lesson, so make sure you're pausing the video to write it down to keep it straight, all the different kinds of quadrilaterals that we'll be talking about. So at the end of this lesson, you'll know what all of those words mean, and you'll be able to explain it to a friend. All right, so here's some of the vocabulary words. The word opposite, parallelogram, rectangle, rhombus, square, and trapezoid. All right, so what does the word parallel mean? Maybe you've heard this word before and maybe you haven't. Parallel is when two lines, we describe them as parallel as if they're running right next to each other and they will never run into each other. So like they're at the same angle. An example of like parallel lines, if you think about like railroad tracks, those are parallel lines that never cross each other. So it's not like they go like this. They're running right next to each other. So if you look over here, I have some examples of some parallel lines. And again, they can go any angle, right? They're just going the same angle so that they don't run into each other. Okay, and here's another example of parallel lines. We'll also be talking about perpendicular lines. Those are lines that cross each other and they make a right angles. So last week, if you remember, we talked about like right angles. Remember, if it makes a square in the corner, then it's a right angle. So when lines are perpendicular, that means they cross each other like a T, or if you think about like window panes or something like that, those make perpendicular lines. They're making a square. Okay? Then another kind of lines when they meet is called intersecting. Okay? So when two lines cross but they're not making a right angle, those are called intersecting lines. Okay? So the difference between these three, parallel never cross each other. They run alongside each other forever and ever and ever. No matter how long you were to extend them, they would never touch. Perpendicular cross, but they make a perfect square, like right angles. And then intersecting cross, and it doesn't really matter what angle they're crossing at. They're just two lines that are crossing each other. All right, so let's look at these. Our first vocabulary word is parallelograms. So it says all of these figures are parallelograms, and I underline the word parallel in it to help you think about what maybe do you think parallelograms means. So if you look at these blue shapes, okay, these blue quadrilaterals, remember a quadrilateral is a four-sided shape. If you look at these, what makes these parallelograms and these not? I want you to think about maybe what the rule would have to be to make something a parallelogram and other shapes like these purple shapes below, not parallelograms. Okay, so parallelograms, if you look, these have parallel sides. Do you see that? So if I were to extend these, I think I have this tool. Let's see if it works. If I were to extend these lines out, they would never touch each other. They would just keep running forever and ever and ever and never touch, okay? What you're probably thinking down here on G, these ones do the same thing too. If I were to extend these opposite sides out, they're parallel to each other. They'll never touch either. They're parallel like this. So what makes these shapes parallelograms and these shapes not? These shapes have two sides or two pairs of opposite sides that are parallel. But then if you look over maybe at J, this one is opposite and it's parallel. And these ones are opposite and they're parallel. See these two lines here? I wish I could make it a different color. These two sides are parallel, so this has two sides. Why isn't this a parallelogram? A parallelogram is a quadrilateral. So a quadrilateral means it has four sides. So a parallelogram is a quadrilateral with opposite sides that are parallel. So both sets of sides are parallel to each other. If you were to extend, if you were to extend these two sets of lines out, they would never touch. Oops. This is a new tool that I'm trying, so we'll see if it works very well, but you would extend these forever. Like, for example, this one, I isn't a parallelogram because if I were to extend opposite sides, so opposite of this side is this side, and do you see how if we were to extend them, they would cross? They're not parallel. They don't run right next to each other, okay? So again, to reiterate, the top blue shapes are parallelograms because they are quadrilateral, so they have 4 sides, and both opposite sides are parallel to each other. So that's what makes a quadrilateral. That's why these purple shapes are not, or that's what makes a parallelogram. That's why these purple shapes are not parallelograms. Okay? So now we're going to write in our journal our dictionary what a parallelogram is. A parallelogram is a quadrilateral with 2 sets of parallel sides. So you got to remember, if it's a quadrilateral, that means that it has 4 sides and both sets are parallel. And there's my example of my train tracks that run alongside each other, but then they never touch. All right, let's move on to the next vocabulary word. So if you didn't write that down, pause the video and make sure to write it down. All right, so measuring the sides of parallelograms. Now, obviously, if I had you in class, we would have rulers out and we would be measuring these, but we can't do that. So I'm just going to show you, for each parallelogram, measure the sides to the nearest centimeter and label their length. If we were to measure this side and this side, okay, and compare them, they would be the same length. Opposite sides of parallelograms are the same length as each other. So this one, let's say it's 3 centimeters, and this one's 3 centimeters. They're always going to be the same. This one, let's say it's 4 centimeters, then its opposite side is also 4 centimeters. So that's a really good hint to help you like in tests or things like that. So let's say this side is 3, like if you saw on a quiz, and this side is 4, but it didn't tell you what this side is and this side is, you would automatically know it is because that is a rule when it comes to parallelograms. The opposite side is the same length. Okay, so the opposite side of this one, so this one would have to also be 3. And then the opposite side of this one is here, so this one would also have to be 4. Okay, hopefully that makes sense. So whenever you see a parallelogram, like I'm sure you've seen it on iReady or things like that, if you were to see one where it only labels 2 sides, let's say this one's 5. I'm just making it up, but if it only gave you the 2 sides, you would still be able to figure out what the other side is because that is a rule of parallelograms. The opposite side is the same length. Okay, so then I would know, even if it didn't tell me, I would know that this side is 5 because it's opposite of that side. Okay, so that's another rule that goes with parallelograms. All right, now let's look at rectangles. All of these figures are rectangles. And you're probably thinking, Miss Cook, we learned this in kindergarten. But we're going to talk about what makes a rectangle a special parallelogram. Okay? So rectangles are special kinds of parallelograms. A rectangle is a special kind of parallelogram because it's a quadrilateral, so it's got 4 sides. It's a parallelogram because if you see the opposite sides are parallel to each other. But then a rectangle also has right angles. Okay? So if you look at all 4 of the angles in here, they make a square. They are right angles, okay, on every single one of these. So even though this rectangle is just kind of tilted on its side, if you look at the angle, it's still a right angle, okay? So that's what makes a rectangle a special kind of parallelogram. So if you have your journal, go ahead and write down this definition. A parallelogram with 4 right angles, so all 4 angles make a square, and 2 pairs of opposite sides that are the same length. Okay, so then you would, down in your bottom part, you're going to draw examples. Now, obviously, I'm drawing with the mouse, so mine won't turn out right because, this isn't a straight line, and that doesn't look like a right angle. But if you were trying to draw one, or you could even trace, if you have like a little eraser next to you or some type of rectangle, that you could trace in your examples. Okay, so a rectangle has 3 rules that makes it a rectangle. It's a parallelogram, okay, so that means it has 2 sets of parallel sides. It's a quadrilateral, right, because it has 4 sides, 1, 2, 3, 4. And what makes it a rectangle is that it has 4 right angles. So that's a lot of rules, right? That's a lot to remember. Let's look at another shape, okay? We also have squares and rhombuses, okay? These figures are squares, and these figures are rhombuses, okay? Look at both pictures and see what you notice that's similar and different about both of those. Okay, so if you notice, there's a square over in the rhombus side, right? So we'll talk about that here in a second. Takashi said squares are special kinds of rectangles. That's kind of weird. Let's see if we can figure that out. And then it also said rhombuses are special kinds of parallelograms. So when she says squares are special kinds of rectangles, well, let's look back at what our rules are for rectangle. A parallelogram is a square parallelogram. Yep, because it has two sides that are opposite, that are parallel to each other. It also says it has 4 right angles. Does a square have 4 right angles? Yep, all 4 are right angles. Okay, and then it says opposite sides of the that are the same length. So are the opposite sides. So if this one was 3, this one would also be 3. And since it's a square, actually all sides are the same length. Okay, so a square is a type of rectangle with sides that are all the same length. Okay, so it's a type of rectangle, all the sides are the same exact length. A rhombus, so if we look at these green shapes over here, are rhombuses. Those are parallelograms, so that means they have 2 pairs of parallel sides, but they're also the same length. But what's different then between squares and rhombuses? If you look at it, squares are a type of rectangle, so that means they all have to have right angles. So a square has to have right angles. Rhombuses don't. But all of these are the same length. This is 3, this is 3, this is 3, and this is 3. But it doesn't have to have right angles. Can it have right angles? Yes, because a square can be a rectangle and it can be a rhombus, which can be really confusing. But it can be both. And I apologize in advance if this video is super confusing. I'll try to find other resources and pictures to post to help you keep everything straight, because there's a lot of rules. So a rhombus doesn't have to have right angles. See how this one's smaller than a right angle? But it can have right angles. That's why a square can be a rhombus. So if we were to make like a Venn diagram, let's just make my little Venn diagram, and we said this one is rectangles, and this one is rhombuses. Okay, a square would be in the middle because a square is both. It's a rectangle because it has 4 right angles, and it's also a rhombus because all the sides are the same length. So it's both things, okay, which can be kind of confusing. So let's write those definitions in our vocabulary notebooks. So square is a type of rectangle, so that means it has right angles, in which all 4 sides are the exact same length. So if one side's 1 inch, then the other side is 1 inch, 1 inch, 1 inch, which you guys learned in kindergarten and first grade, that squares are all the same length. A rhombus is a parallelogram with sides that are all the same length. So a rhombus also has all sides the same length, but it doesn't have to have right angles. Okay, it can have some acute angles or obtuse angles. All right. So pause the video if you haven't written down those definitions. Make sure you draw examples. If you don't know how to draw examples, maybe you can go back in the video and look at some, but you guys all know how to draw squares. And again, my pictures aren't going to be perfect. And then rhombus, you can make it, they're all the same side, or all the sides are the same length, but the angles don't have to be right angles. That was a very bad picture, so don't do one like that. Okay, let's look at more. All right, let's do a brain break. I need one too. I feel like I'm having a hard time keeping all of this straight. All right, so we're going to do some would you rathers, and then I'll come up with some activities you do, whichever one you pick. So, would you rather have a magic carpet that you could fly around on, or a robot that would do your chores? If you'd rather have a magic carpet, I want you to do 10 jumping jacks. If you'd rather have a robot, I want you to jump towards the ceiling 10 times, as high as you can. All right, here's our next one. Would you rather have an extra finger or an extra toe? If you'd rather have an extra finger, I want you to do 5 push-ups. And if you would rather have an extra toe, I want you to do 5 butt kicks. So if you don't know what a butt kick is, it's like you're running and you're kicking yourself in your bottom, okay? All right, would you rather live in the sky or under the sea? If you'd rather live in the sky, I want you to do 5 high knees. So that's when you're running in place, but you're trying to get your knees to touch your chest. So get your knees as high as you can. If you'd rather live under the sea, I want you to pretend to be swimming for 10 seconds. Okay, and then the last one. Would you rather meet a superhero or a cartoon character? If you'd rather meet a superhero, I want you to do 5 push-ups. If you'd rather meet a cartoon character, I want you to run in place for 10 seconds. All right, pause the video if you need to. If not, we're going to go ahead and do the second half of this lesson. All right, so now we're going to just practice with those words that we learned about to describe quadrilaterals. So use as many words below as possible to describe each figure. Okay, so looking at this shape, we're going to use which one of these, well, there can be more than one, which of these words fit with this one. Okay, so let's look at the first one. We say we have quadrilateral. Is this shape a quadrilateral? Yes, right, because a quadrilateral just means it's a polygon with 4 sides, and this one has 1, 2, 3, 4 sides. So yes, it is a quadrilateral. Okay. Then it asks, is it a parallelogram? Well, we learned earlier in this lesson, a parallelogram means that it has 2 sets of opposite sides that are parallel to each other. Does this one have 2 sets of sides that are parallel to each other? Yes, so it is a parallelogram. Okay, next one is rectangle. Well, we know that the definition for a rectangle is that it's a parallelogram. Okay, but it also has 4 right angles. Does this one have 4 right angles? Yes. So this one's actually also a rectangle. And last one, square. The definition for a square is a rectangle that it has all sides of the same length. Are all sides the same length on this one? No, so it is not a square, right? Because this side is way longer than this side. All right, let's do another one. Okay, let's look at this shape. Is this shape a quadrilateral? Well, a quadrilateral means that it has 4 sides. So does this shape have 4 sides? 1, 2, 3, 4. Yes, so it is a quadrilateral. All right. Is this shape a parallelogram? Remember, the definition for a parallelogram is it's a quadrilateral with 2 pairs of parallel sides. Does this one have 2 pairs of parallel sides? No, right? Because if you look at these 2 sides are opposite and they touch each other. So they're not parallel to each other. And same with these ones. So nope, it's not a parallelogram. We remember the definition for a rectangle is it's a parallelogram with right angles. Well, this we already said is not a parallelogram, so it can't be a rectangle. And if we look, it doesn't even have right angles either. So no, it is not a rectangle. And last one, is this a square? Well, let's look. A square is a type of rectangle with 4 equal sides. Well, we just said that this isn't a rectangle, right? So it can't be a square because a square is a type of rectangle. Now, this might be getting really confusing, and that's okay. If it is, I'm going to try to post some other videos too that will help you keep all of this straight. So this one is just a quadrilateral. It doesn't fall in any of the other categories. Let's look at this one. This one is a quadrilateral. 1, 2, 3, 4. So yes, because it has 4 sides. Okay, is it a parallelogram? Remember parallelogram? 2 sets of parallel sides? Yep, this side is parallel to this side, and this side is parallel to this side. Okay, so yes, it is a parallelogram. All right, is it a rectangle? A definition of rectangle is a parallelogram, which we already said is parallelogram, but that has 4 right angles. Does this one have 4 right angles? Yes, so this is a rectangle. And is it a square? The definition of a square is a type of rectangle that has all equal sides, so all the sides are the same length. Would you say that all these sides are the same length? Yes, so this one's a square. Okay, so this one's actually all of them. It's a quadrilateral, it's a parallelogram, it's a rectangle, and it's a square. Okay, let's look at this one. Is this a quadrilateral? Quadrilateral has 4 sides. 1, 2, 3, 4. Yep, it is a quadrilateral. Oops. Okay, is it a parallelogram? Parallelogram is that all the sides are parallel to each other. Let's see. This one is parallel to this one. Okay, so we got one set. And this side is parallel to this side, right? They would never run into each other if you were to extend them forever. So yes, this shape is also a parallelogram. Okay, is this shape a rectangle? The definition of a rectangle is a parallelogram that has right angles. Does this one have right angles? No. Do you see how this one is like squeezed? Remember, a right angle makes a square, and this one is squished in a little bit. And so is this one, and these ones are obtuse. So this one is not a rectangle. So can it be a square if it's not a rectangle? No, right? Because a square is a type of rectangle. So it can't be. Kind of like, if you want to think about it, is like a quadrilateral, or yeah, quadrilaterals are, if you were to compare it to animals, okay? It's like if you said you have an animal, well, that could mean a whole bunch of different kinds of animals, right? Quadrilateral, there's a whole bunch of different kinds of quadrilaterals, okay? You have parallelograms. So if you think of animals and then you did a subcategory of, let's say, dogs, okay? Parallelogram is a type of quadrilateral, just like dogs are a type of animal, right? It's a kind of animal, okay? Then there's rectangles, which is a type of parallelogram, just like corgi, or let's say black labs, or labradoodles, or whatever, Labradors are types of dogs, okay? I might be losing you already, okay? Types of dogs. And then we could say square is a type of rectangle, just like a black lab is a type of lab, okay? So that can be really confusing, and I'll post a graphic after this. I might have just made this way more confusing than it was supposed to be. All right, we have one more different type of quadrilateral that we're going to talk about. The quadrilaterals below are called trapezoids, okay? What do you notice about trapezoids? Okay, trapezoids have 4 sides, right? 1, 2, 3, 4, 1. They all have 4 sides. But what's different about them? What makes them not a parallelogram? Trapezoids only have one set, exactly one set of parallel sides. Okay, so here's a parallel side to this parallel, but these ones are not parallel, right? If I were to take my little, where did it go, connector? If I were to connect, or like extend these lines out to see if they're parallel, do you see how these sides would eventually touch each other? So they're not parallel to each other. These sides, however, are parallel to each other. Oops, I got off a little bit. Okay, these sides are parallel to each other. So a trapezoid is a quadrilateral, so it has 4 sides, but it only has one set of parallel lines rather than 2, like a parallelogram, okay? So let's write trapezoid in our vocab book. A trapezoid is a quadrilateral with exactly one pair of opposite sides that are parallel, okay? Just has one pair. Parallelogram has 2 pairs, right? Trapezoid only has 1. So that's what makes them different. So earlier when we said parallelogram is like if you were to compare it to a dog, a trapezoid is a cat. Okay, they're similar, but they have a little bit of differences. All right, so let's look at which ones of these are trapezoids. If a trapezoid is a quadrilateral with one pair of parallel sides. Okay, well, let's look. If we were to extend these ones, oops, I didn't even extend it. If I were to extend these sides, would this be parallel to each other? No. Okay, so then let's test the other side. Are these parallel to each other? No. So this is not a trapezoid because it doesn't have even one side that are parallel. Let's look at this one. Does it have one set of parallel sides? Yes. Do you see how the top one and the bottom are parallel to each other? Okay, so this is a trapezoid because this one, these sides, though, aren't parallel. So it only has one set of parallel lines, the top and the bottom, so that makes it a trapezoid. Let's look at Y. Is this a trapezoid? No, Y is not a trapezoid because if you look, it has, these are parallel, and these are parallel. That means it has two sets of parallel sides. So what is it? What is y? It's a parallelogram because it has two sets, and we're looking for ones that only have one set. That's what makes it a trapezoid. If I extend these lines out, these are parallel to each other, but then if I were to extend these to see if they're parallel, they're not, because they would eventually touch. So the Z is also a trapezoid because it only has one set of parallel lines, okay? All right, so hopefully this kind of helps you a little bit. We looked at all different kinds of quadrilaterals, okay? We didn't even look at the kite, so you can ignore that. But we did look at trapezoids as one kind, and parallelogram is another kind. Parallelogram has the two sets of parallel sides. Trapezoid has one set of parallel sides. Then there's different kinds of parallelograms. There's rhombuses, okay, which means they don't have to have a right angle, but they have all the same equal sides. There's also rectangles, which means they do have to have right angles, and the opposite sides are the same length, but not all of the sides are the same length. And then we have square, which is both a rectangle and a rhombus, okay? I really hope that I didn't make this too confusing. This is kind of hard to teach when you can't do hands-on stuff with you guys and I can't explain it in a longer time setting, right? I have to make short videos. So if you are really confused, please make sure to reach out to me. But let's do these really quick. So quadrilateral, is this one a quadrilateral? Yes. Is it a parallelogram? It has two sets of parallel sides, so yes. Is it a rhombus? A rhombus means that it has four equal sides. No, this is not a rhombus. Is it a rectangle? So is it a parallelogram that has right angles? Yes. And is it a square? Is it a type of rectangle that has all four equal sides? No, so this is not a square. Go ahead and pause the video and try to see which one for all of these shapes, which categories it does fall under and which categories it doesn't fall under. Go. All right, so hopefully after that activity, and hopefully I didn't confuse you too much, this wasn't my best lesson, that's for sure, you can explore the relationships between parallelograms, rectangles, squares, rhombuses, and trapezoids. So please let me know if this lesson was super confusing to you. Hopefully it wasn't too bad. I'll also try to find some other resources to post with this in case this was confusing, but then you have a Google form to fill out really quick to show what you know. Have a great rest of your day.